This is Algebra 1, looking at Lesson 5, which was on multiplying polynomials, specifically binomials and trinomials. And I got a couple questions here from y'all, and these are great questions. You want me to do some homework problems, specifically numbers 5, 15, 19, and 21. So I'm going to do those in this video. So 4 questions. Here we go. So in Lesson 5, 15, 19, and 21, awesome. We have number 5 actually done right here. We did this today in class. So we did the distributive property as shown below with our color coordination. So I'm actually going to move past this. One of our students asked about number 15. We're going to do that tomorrow in class, but I'll still take this opportunity to go over in this video. We are multiplying the trinomial x squared minus x plus 1 times the binomial x minus 1. And here's how we could do so. Making all the possible distribution, aka multiplication combinations. We do x squared times x plus x squared times negative 1. Okay, all those x squareds are done. So now we move on. Negative x, so plus negative x times x plus, just again making all the possible multiplication combinations, negative x times negative 1. And now the x's are done, or the negative x's are done, so we move on to our last number here in our trinomial, 1 times x. And last but not least in pink, 1 times negative 1. All right, let me kind of smush this down here. Got a humongous multiplication problem going on here. But now basically it's an execution of PEMDAS in conjunction, meaning together with our exponential properties. So we're going to do all the multiplication first, and then we'll see if we can add the like terms. So x times x gives us x to the third power, and again, sorry, x squared times x gives us x to the third, and the reason for that is when we multiply like bases, we add those exponents. 2 plus 1 is 3. All right, x squared times negative 1 is just going to be a negative 1 x squared, or a negative x squared. Negative x times x, negative in front, so we have a negative times a positive, which will result in a negative, and again, x times x gives us x squared. Purple here, negative x times negative 1, negative times negative is positive, positive 1x, because negative 1 times negative 1 is 1. Orange, 1 times x, well that's just 1x or x. Notice I'm not throwing any of the ones or the negative ones in front, just the signs themselves. And last but not least, 1 times negative 1 here at the very end, our pure integer multiplication is negative 1. Now here comes the process of combining like terms. I have x squareds and I have regular x's, so let's combine those. Notice x to the third, or x cubed, doesn't have anything to combine with, so I leave it the same. I'm going to combine my negative 1x squared and my other negative 1x squared. Let's just focus on the numbers. Negative 1 minus 1, aka negative 1 plus negative 1, is negative 2, and x squared comes along for the ride. X plus x, 1x plus 1x gives us 2x's, and last but not least, that negative 1 has nothing to combine with, so it comes on down. Problem number 15, done. All right, I believe the last two that we wanted to do were 19 and 21. So there's number 15. Pause that if you want to get that work done, but otherwise I'm moving on down to number 19. All right, number 19 is a difficult one because now we have two binomials, 2z plus 1, a 2-term parenthesis, and another binomial, 3z minus 2, all of that being times a single term expression z. So what I'm going to do is I'm going to take it one step at a time, and I'm going to basically focus my attention on just the first two, doing multiplication similarly to how we would if this was a problem that we were looking at. We'd say, all right, 3 times 4 first is 12. 12 times 2 is 24. We do multiplication one step at a time. Now the same thing is going to be done here, just now, obviously a little bit harder, but with distribution. So first one, I'm going to look at, I'm going to distribute z to 2z. Z times 2z is 2, and then z times z is z squared. And then I'm going to take that z out front and distribute it to 1, and that's going to give me just 1z, or z. So now what we've done here through that distribution is basically we have worked down just, let me make that a little bit clearer, sorry about this, for the pause. Once again, we have worked down basically just that first multiplication problem into here. Cool. Now it's time to finish our distribution through the mnemonic device that we call FOIL. First times first, 3 times 2 is 6. That was number times number. And then variable times variable, z squared times z is z to the third. All right, on to the next one. Here we go. Ready? 2z squared times -2. Number 2 times number -2 is -4. Notice that there is no z over here. So it's just going to cut this z squared will just drop down in our product. All right, making good headway. Let's do z times 3z. Notice this is basically a 1 or no number in front. So 1 times 3 is 3, effectively meaning just drop that 3 on down. And then we have z times z, which is z squared. And last but not least, z times -2 is -2z. The final step will be to combine like terms. Hey, look at that. We got some like terms right here, the z squareds. So we have the numbers or the coefficients in front that we're working with. -4 plus 3 is -1. And z squared comes down for the ride. 6z to the third had nothing to compare with, so it's there. -2z had nothing to combine with, so it's there. We bring them on down, and as we mentioned today in class, we're going to leave it in this descending order with the highest power leading the way, and each successively lower, power of 3, power of 2, power of 1, but not needing the 1 there shown. Number 19. All right, sorry about that, that was unlucky. Okay, number 21, we want to use the distributive property and our widths to write each of the following expressions as a sum of monomials. It is if the resulting polynomial is in one variable, write the polynomial in standard form. All right, for this problem, we only need to do parts A and B. So this whole expression, a plus b squared, is the same thing as a plus b times itself. And a plus 1 squared is the same thing as a plus 1, that whole parenthesis, times itself. Because notice we are squaring the parenthesis. Okay, so we are now going to use FOIL here, or the distributive property. A times a is a squared. A times b is, well, they're not like terms, so we'll just stack them in alphabetic order, a, b. B times A is BA, but keep in mind, y'all, the commutative property, says the order in which we multiply doesn't change our answer. So B times A is the same thing as A times B. And I'm really just going to do that for the ease of combining like terms at the very end. And last but not least, B times B is B squared. And the reason why I switched BA into AB here on that previous step was for the next process where we say, all right, let's combine like terms AB plus AB. If you have one AB and then you add another AB to it, guess what you have? 2 ABs. So A squared had nothing to combine with, so it comes on down. Plus 2AB plus B squared had nothing to combine with, because notice, although there are A's and B's in some of the other terms, they're not identical, so it also comes on down. 21A, done. Last but not least, 21B, same process, just a little bit different. A times A squared. A times 1 is just 1A. 1 times A is also just 1A. In rapid fire, as you see me FOIL and AK distributing quick, 1 times 1 is 1. Guess what? We have like terms here once again. A plus A makes 2 A's. And now we can write this at the directions asked in standard form, because it is just a single variable expression where our highest power is out front, down to the power of 1, down to no power. This is our standard form there of our quadratic expressions.